Hello. So what I want to do right now is I want to talk about some percentage problem related material. I want to introduce you guys to percentages. I know you guys probably already know about percentages, but I'm going to give you some rules that we're going to follow to solve some common percentage problems. And I want to fix some language related to these kind of problems so that we can have so that as I work out problems that are related to percentages, you'll understand where I'm coming from, and also we're going to justify each of these rules. So first of all, we're going to let x be a number, and we're going to let b be some percentage, and yes, we want to fix some language, okay? And the rules I'm going to show you are going to be justified later. So for example, one kind of problem that we want is we want to find out what is p% of x, right? What is p% of like the number x, right? This is one kind of problem we will often face, okay? And so the way we're going to handle it is we're going to write p in decimal form, okay? And we're going to multiply it by x, okay? So for example, what is 5% of 173? Okay, what is 5% of 173? We're going to convert 5 to a decimal. Okay, so 5% as a percentage is the same thing as 0.05 as a decimal. Okay, so we can imagine that this is my p decimal and my p is 5. So if my percentage is 5, my p decimal is 0.05, and I got that by moving this imaginary decimal place once, twice. And when I had to move it twice, there was no number there, so I put a 0. And so what is 5% of 173? Well, in this particular setup, we can see that my p was 5, and we can see that my x, my particular number, was 173. So our 5% of 173 will be p decimal times x, which we will see is 0.05 times 173. Okay. Let me carry out that calculation here. 0.05 times 173. 5 times 3 is 50, so I bring down my 5, carry my 1. 5 times 7 is 35, plus 1 is 36, so I carry the 3. 5 times 1 is 5, plus 3 is 8. Now, I know if I multiply this times 0, it's going to be zeros. If I multiply this times 0, it's going to be zeros as well. I'm going to have there's two total decimal places in my two factors that I'm going to multiply. So I'm going to move it twice to the left. So 1, 2. So it's 8.65. So we can say that 8.65 is 5% of 173. Okay? That's how we handle this example. And this is the kind of setup. What is p% of x? Well, it's the p decimal times x. So we're going to call this our rule 1, okay? And we're going to have a separate video where I justify it for you, okay? And now we're going to move on to example 2. So now we're going to have this kind of question often come up. What is x increased by p%? And it is, in our language, it is 1 plus p decimal, that times x, okay? So for example, if you have a typical problem for this will be a dress normally retails for $256. If the price is increased by 4%, what is its price now? So if our p is equal to 4, then we know that our p decimal, okay, will equal to 0.04, okay? And then what we're going to, and we know of course here our x is 256, right? So now we know that that the amount, so if it's increased by 4%, then I'm going to calculate it like this. it'll be 1 plus p decimal, which will be 1 plus 0.04 times 256. But what is 1 plus 0.04? It's 1.04. So it'll be 1.04 times 256. Okay. Let me do that for you here. Okay. So 1.04 times 256 is going to be 4 times 6 is 24. Carry the 2. 4 times 5 is 20. Plus 2 is 22. I bring down the 2. Carry the 2 from the 20. 4 times 2 is 8. 9, 10. 10, 24. This 0 times 6 is 0. This 0 times 5 is 0. This 0 times 2 is 0. And then you bring down 1 times 6 is 6. 1 times 5 is 5. 1 times 2 is 2. One of the things I want you to observe here as I carry out this multiplication is that I try to make sure everything is lined up very nicely, because I know when I add, if I don't have it lined up perfectly, there's the huge risk that I'm going to make a mistake. So here there's going to be 4, 2, 6, 6, and 2. Now notice, in these two factors that are being multiplied, there are a total of 2 decimal places, the 0.04. So I'm going to move this twice to the left, and it'll be 266.24. So this, the new price of this dress, which has increased by 4%, is $266.24. Okay? And I know usually, dress stores undergo sales, and this is what I like to call an anti-sale. No, I'm just kidding. But so this is the rule when we want to increase by a certain percentage. Now we're going to move on to the next rule. So a dress which normally retails for $357 is now on sale with a discount of 7%. What is the sale price? So here, this is the rule that we're going to use, the rule 3. What is x decreased by p%? It is 1 minus p decimal times x. Here we can see that our p is equal to 7%. That means that our p decimal is equal to 0.07. Our x is 357. Okay, so our result, the sale price, okay, of our dress is going to be 1 minus the p decimal, which is 1 minus 0.007. 0.07 times 357, which is our x. Okay. Now, what is 1 minus 0.07? Well, that is exactly 0.93, and that's going to be times our 357. Okay? Okay. And now, in order to calculate the sale price, we're going to have to actually work that out. Let's do that here together. 357 times 0.93. Okay? So I'm going to put that here. Now, let's effectuate this multiplication. 3 times 7 is 21. Bring down the 1, carry the 2. 3 times 5 is 15. I add the 2, I get 17. 7 down, 1 up. 3 times 3 is 9, plus 1 is 10. Okay? Now, 9 times 7 is 63. That's 3, carry the 6. 9 times 5 is 45, plus 6, 51. I bring down the 1, carry the 5. 9 times 3 is 27, plus 5 is 32. I bring down the 2, carry the 3. I bring down the 2 and the 3 goes over. 1, 7 plus 3 is 10. I bring down the 0, carry the 1. 1 plus 0 is 1, plus 1 is 2. 1 plus 2 is 3. 3 comes down. I had a total of 2 decimals in the factors that were being multiplied. So I move it 1, 2, and I get 332 and 1. That is my sale price. And so that is the content of Rule 3. And yes. So now here, we're going to have Rule 4. What is y as a percentage of x? Well, the p decimal will be y divided by x, or alternatively, the p will be y divided by x times 100, where p is the percentage, right? So now we're going to look at that example. Total sales were $45, or it could be 45 euros, whatever you want. 45 lira, 45 pesos. So total sales were 45, the profit was 9. What was profit as a percentage of the sales? We see that we want to know profit as a percentage of the sales. In other words, y as a percentage of x, where the profit is the y, the sales is the x. So therefore, my y will equal to 9. My x will equal to 45. And so I can already know that my p decimal is going to be y divided by x, or in other words, 9 divided by 45. Now, in order to get the p decimal, I'm going to have to do a long division. Let's do it together. The 45 will go on the outside. The 9 will go on the inside. Okay? Does 45 go into 9? It doesn't. So what we're going to do here is we're going to put our decimal point, right? Once we place a decimal point, we can affix a 0 that wasn't there before. We ask ourselves, does 45 go into 90? It does. It goes twice, because 2 times 45 is 90. So that's 90. And 90 minus 90 is 0. And so we can see that the p decimal is going to be 0.2. Okay. So we got our p decimal as 0.2. Or if we wanted to, we multiply by 100. We're going to move the decimal place twice, and we will get our p as a percentage is 20%. Because if I move the decimal twice to the right, it'll be 20. Okay? So the profit was 20% of total sales. Okay? And now, let us advance to the next rule. So you will often have this other kind of problem, which is like, if you have y is p% of some number x, what is x? In other words, you're assuming that you've got y and p, and you want to know what the unknown x is. The answer is that x is going to be the y divided by the p decimal. So suppose that 30 is 25% of some unknown quantity, and we want to know what it's 25% of. Okay? So first of all, we know that, in other words, we can see that, okay, anyway. So here, my y would be 30, okay? And my p is 25. We want to know what x is. We know that if p is 25, then our p decimal will be 0.25, because I'm going to have to move the decimal place twice to the left to get the p decimal. So now my x, my unknown quantity, is going to be my y, which is 30, divided by 0.25. Okay? And now we're going to have to do the long division to make this work out. It will make it easier for us if we multiply the bottom by 100, so that it'll become, instead of 0.25, so it'll become 25. And if I multiply the bottom by 100, I'll multiply the top by 100. So I'm going to have 3,000 divided by 25. So now, let me carry out this long division here, okay? Okay, so 25 goes into 3,000. 25 goes into 3, it does not. 25 goes into 30, it does. It goes one time. 1 times 25 is 25. 30 minus 25 is 5. I bring down a 0. And I ask myself, does 25 go into 50? It does. It does twice. 2 times 25 is 50. 50 minus 50 is 0. But there's still a 0 here, so I bring down the 0. Does 25 go into 0? It does not. So I put in 0. 0 times 25 is 0. I mean, it's 0, yeah. So then 0 minus 0 is 0. And then there's no 0 to bring down. So the long division terminates and with no remainders. So we can say that that 3,000 divided by 25 is 120. So we can say that 3,000 divided by 25, or in other words, 30 divided by 0.25 is 120. So therefore, the 30 is 25% of 120. And with that, we have discussed the percentage rules that we're going to use in solving problems. I will give justifications of each of these rules, but you can also use these rules to solve but also we're excited because we'll be able to use them to solve problems. Thank you so much, and I'll see you soon.